Welcome to class. How are you today? We are still in the business as usual. This topic we started from what a redox reaction is all about. Thank God today we are actually gradually and soon we shall be rounding up the topic. Today we'll be discussing oxidizing agents and the reducing agents. As I said in our previous classes, every oxidation reaction that occurs, there must be an agent causing it. And for every reduction reaction that is actually taking place, there is also a reducing agent. Today we shall look at these agents, how they can be identified, and chemically, how they can be tested for. So today, we're going to start with the oxidizing agent. We're going to start with the oxidizing agent. An oxidizing agent is the substance or the particular element that can cause oxidation in a reaction. In fact, when it comes to chemical equation that depicts or that showcases a chemical reaction, of course, you know that in a chemical reaction we have the left-hand side and the right-hand side. The left-hand side, which are the reactants, and the left-hand side, which are the reactant, and the right-hand side, which are the products. These agents are basically the reactants. We will always find them at the left-hand side. In the left-hand side of the reaction, you will always notice a particular agent, either a reducing agent or oxidizing agent, provided that reaction is a redox equation or redox reaction. So today, we are going to explore, we are going to look at, we are going to go deeper to know these substances, these elements, these compounds, because these oxidizing agent and reducing agent can be compounds and can also be what? Elements. Now, note the first point I made, that in a chemical equation that is a redox equation, that you will always find an oxidizing agent or reducing agent at the left-hand side, which are the reactants. I'm not saying that you may not find it at the right-hand side, but basically this is where you find them. They are usually the reactants. So in every redox reaction, there are two main reactants, the oxidizing agent and the reducing agent. We are looking at oxidizing agent, the oxidizing agent. Oxidizing agents. Okay, look at the definitions we have. I'll be giving you about 2 to 3 definitions that will help us to understand what oxidizing agents are. The first one I have, it says, oxidizing agents are the electron acceptors. They are the electron acceptors. In every redox reaction, electrons are used to balance the redox equation. These electrons are placed where you have more positive charges. Why are you introducing the electron, the direction where you have more positive charges? You are doing that because electron carries a negative charge. In other words, electron gives a number a negative value. And when the negative value is added to a positive value, you should expect the value to reduce. So introducing an electron where you have more positive charge, you will cause the positive charge there, which is oxidation number there, to do what? Come down so that it can be equal to the charge which the reaction carries in the other side. Looking at what I have on the board, we say that an oxidizing agent is the one that accepts electron. Look at that reaction. I have copper 2 moving to neutral copper, Cu. Look at it very well. You will observe that at my left-hand side, I have copper 2. The oxidation number of copper 2 there is +2. Is +2. Now, what is the oxidation number of copper at my right-hand side, which carries no charge? The oxidation number is 0. So tell me, between my left-hand side and my right-hand side, where do I have more positive charge? Of course, at my what? Left-hand side. It is at this left-hand side I'm going to introduce an electron in such a way that after the calculation or interfering with the +2, it will now be equal to what? 0, which the right-hand side bears. So I have +2. How many negative values should I introduce to +2 in order to achieve 0? That is 2. That implies that I'm going to add, at my left-hand side, I'm going to add +2 electron. Remember what I said? Electron gives a value negative what? Number, because electron is from the fundamental particles of an atom, and electron has been found to be negatively charged. So if I should have +2 minus 2, I will be having total of what? 0, which then corresponds to 0 at my what? Right-hand side. In that case, what is the particular substance in that equation that has taken that electron? Where did we add that electron to? To copper 2 at my left-hand side, or to neutral copper at my right-hand side? Of course, the electron, 2 electrons were actually added to what? Copper 2, which is what? At my what? Left-hand side. And that shows that this copper 2 ion is a good oxidizing, is a good reducing agent. Is a good what? This one here now is a good what? Oxidizing what? Agent. Is a good what? Oxidizing agent. What I'm trying to say is this. This particular copper 2 ion, which I added to electron, is what? A good what? Oxidizing agent. If you look at what we have on the slide, you will see said is normally a non-metal or positive ion. Non-metal or positive ion. Non-metal or positive ion. It's usually a non-metal or positive ion. So either it's a non-metal or a positive what? Ion. So what I have here now is a positive what? Ion. What I have here now is a positive ion. Positive ion. If you watch, every oxidizing agent is reduced. So that is one aspect I want you to understand about an oxidizing agent. Now let us go deeper to know this oxidizing agent using specific equations, full equations that are Redox equation. It says that an oxidizing agent is usually a non-metal. There are more of non-metals. Yes, you may argue a little about the copper 2 ion there. It's not just ordinary copper, it's copper 2 ion. Copper 2 ion. The copper 2 ion is actually accepting what? Electron. Right? Is actually accepting electron because oxidizing agents, they are electron acceptors. They gain electron. That is the next point you can see on the slide there. The first one says is normally a non-metal or positive ion. Now, this particular equation here is taking care of positive what? Positive ion. Because here is copper 2 ion. It's not just ordinary copper. Okay, now what will help you to understand that it's really an oxidizing agent is because an electron or 2 electrons were actually added to it. Okay, that takes care of the one that says the agent itself is an electron acceptor, that the agent gains electron from other atoms or ions. The agent gains electron from other atoms or ions. Okay, let's go to the next slide. Let's go to the next slide. Look at what is going on there. Examples of oxidizing agent from Redox equation. Look at the first equation where hydrogen sulfide is reacting with chlorine to give us hydrochloric acid or hydrogen chloride and the what? Sulfur. And the sulfur. The first one I want us to look at is where we say that an oxidizing agent is that which accepts electron, is that which accepts electron. Okay, let us look at ion 3 moving to ion 2. Between ion 2 and ion 3, which one is an oxidizing agent? Which one is an oxidizing agent? Now, the one that will tell you and that will clarify this is the one that will accept electron in order to make sure that that Redox equation is balanced. So tell me, look at it. I have ion 3 by my left-hand side and I have ion 2 at my right-hand side. Here I have ion 3. What is the oxidation number? Plus 3. At my right-hand side, I have ion 2. My oxidation number is plus 2. I want both sides to have equal oxidation number. Both the left-hand side and the right-hand side. So, I have already told you that we introduce electron when we want to balance Redox equation. And the electron carries negative. That means if you are putting electron in a number, you are trying to reduce that number. So where should I put electron now in order to do what? Balance the other one. I should put electron at my left-hand side, which is what? At the where I have my plus 3. So how many electrons do you think that can fit in here in order for me to have plus 2 at my right-hand side? That means it's only one electron. So I have plus 1 electron. That is E what? Minus. What does this mean? It means plus 3 minus 1. Because this negative will definitely interfere with this plus. And you have minus. So what do you have now? You have plus 3 minus 1, which is equal to plus 2. Which now corresponds to what we have here. So where exactly am I introducing the electron? Is at my left-hand side. So that shows that ion 3 gains this electron in order to become what? Ion 2. So that means ion 3 is a good oxidizing agent. Okay, now let me write the full equation. This is a situation where ion 3 chloride or ion 3 chloride, let me go by ion 2. If I have ion 2 chloride, FeCl2 reacting with Cl, which is chlorine, to give me FeCl what? 3. From ion 2 chloride to ion 3 chloride. Okay, can you see that? That means this ion 3 chloride is my oxidizing agent, while the ion 2 is what? Reducing agent. What have we said so far? We have been able to define oxidizing agent as that substance, that element, or that compound that has the ability to gain electron in a redox reaction. Looking at a redox equation, you'll always discover that oxidation number of a particular element in a compound changes from left to right or right to left. You see a change in oxidation number. And once there is change in oxidation number, definitely oxidation or reduction reaction has actually taken place. So you discover which part is taking the electron. And which part did I mention? The part that carries the highest positive charge should take in the electron. And when it takes in this electron, it reduces the total positive number at that particular element so that it can now correspond with the charge at the other side. In summary, that particular element, that particular compound that gains the electron, that takes in the electron, it is the one considered to be what? An oxidizing agent. That is the point we are talking about here. It is the agent that gains the electron from other atoms. We have already said it is normally a non-metal. Yes, most of oxidizing agents are non-metal. We shall look at that soon. Now, another point I want us to see here about oxidizing agents is that oxidizing agent in every redox reaction is reduced. An oxidizing agent in every redox equation which shows a redox reaction is reduced. What do we mean by reduce? Reduce in the sense that as you move from left to right, you notice that that particular element, its oxidation number will actually decrease. Look at the good example I have here. I have copper 2 here, and moving to my right-hand side, what do I have? Copper. What is the oxidation number of copper 2 plus 2? Now, moving to my right-hand side, what do I have here? What's the oxidation number of a neutral atom here? 0. Can you see that? That means the oxidation number of copper actually decrease or reduce from plus 2 to what? 0. This is another way you can recognize oxidizing agents. The substance, be alone or be in a combined form, pick out that particular element, calculate its oxidation number at the left-hand side, move to the right-hand side, check where that particular element can still be found, whether in a free state or in a combined form, calculate its oxidation number. If there is a decrease in the oxidation number from left to right, that means where you started, just like here now, is the what? An oxidizing what? Agent. An oxidizing agent. Okay, I have mentioned about key 3 points here, how you can identify oxidizing agents. They are reduced in a redox equation. They usually gain, they are agent that gains what? Electron. The agent that gains what? Electron. And their oxidation number actually decreases in a positive direction. Yes, the oxidation number decreases in a positive direction. Look at it here. Moving from left to right in this particular reaction, we are moving from left, which is plus 2, copper 2, then moving to the right is in the positive what? Direction. You see that the oxidation number is actually what? Decreasing. Okay, the equations will help us. Here, hydrogen sulfide is reacting with chlorine to give us hydrochloric acid plus sulfur. And I pointed at chlorine gas as being the oxidizing agent. Why is it the oxidizing agent? Why is it the oxidizing agent? There are 3 things I mentioned. Let us look at those 3 things. If this chlorine actually qualifies to be an oxidizing agent. Let's look at the oxidation number of chlorine from here. Then we'll move it to the right-hand side and see what is the oxidation number of chlorine in hydrochloric acid or hydrogen chloride acid. Now, a neutral atom, here, look at it, a neutral atom here, the oxidation number is actually 0. The oxidation number is actually 0. A neutral atom has oxidation number of 0. I am taking this from a reaction between hydrogen sulfide plus chlorine that gives me hydrochloric acid then plus sulfur. And this particular element is being pointed to be an oxidizing agent. Let us check then. Let's look at it if it actually qualifies to be an oxidizing agent. As long as it does not carry charge and is in a free state, its oxidation number is 0. Let us go to the right-hand side now. Follow me. The right-hand side, where can you find chlorine again? You find chlorine in a compound called hydrochloric acid. Hydrochloric acid. So can we calculate the oxidation number of hydrochloric acid there? Remember the rule? The rule says you add all the oxidation number and they sum to 0 because the compound itself is a neutral compound. If I should do that, hydrogen loses 1 electron, which is +1, plus chlorine, which I am looking for, all is equals to 0. So that means 1 plus chlorine is equals to 0. So what is chlorine therefore? Chlorine now is equals to what? 0 minus 1. Of course, +1 crossing sign of equality will definitely become -1. So what is the oxidation number now? Cl is equals to -1. So what happened? Is it an increment or decrement? From 0, moving from 0 from the left-hand side, going to the right-hand side to be -1. Of course, 0 is greater than -1. 1 is -1 is less than what? 0. So the number increase, the number decrease from 0 to -1. Does that correspond to one of the definitions I gave you as oxidizing agent? Yes, we say that it is that substance that its oxidation number decreases from left to right. Decreases from left to right. So this particular first equation has actually proven that. So the second one, look at where I pointed at to be the oxidizing agent. Why? It is the agent that takes in the electron. How many electrons? 2 electrons in order to become a neutral copper. So this is the particular one. The copper 2 ion here is the particular one. The copper 2 ion is the particular one that is taking the electron. I have copper 2 is the one that is taking the 2 electrons in order to have a neutral copper. Therefore, this is an oxidizing agent. This is an oxidizing agent. Okay, look at the third equation. The third equation, we pointed at zinc oxide. Zinc oxide to be an oxidizing agent. Remember one of the definitions? It said an oxidizing agent is reduced. An oxidizing agent is reduced. What does that mean? It means that its oxidation number will definitely reduce. Now let's see. From zinc oxide, that is the third equation on our slide. Look at it. I have carbon reacting with zinc oxide. That gives me carbon 4 oxide plus zinc. Looking at my left-hand side, I can find zinc inside zinc 2 oxide. Here, there is zinc here. Let me move to my right-hand side. Where can I find zinc? This is zinc. Let us get the oxidation number of zinc here. The way I calculated the first one, the compound itself is a neutral compound. Is a neutral compound. So since it's a neutral compound, I'm going to add all the oxidation number and equate them to 0. I am looking for that of the zinc. That is what I'm looking for. Zinc. Then plus oxygen gains 2 electrons. That is -2. All of them is equals to 0. So what is my zinc now? My zinc becomes -2. Crossing sign of equality becomes what? Becomes what? Plus what? 2. So here the oxidation number is +2. Let us go to the right-hand side where I have zinc. There zinc is alone. In as much as that zinc is alone, is in a neutral form, that zinc has oxidation number of what? 0. So if here is 0, what is our observation? That shows that oxidation number of zinc in zinc oxide to zinc, that is moving to the left-hand side, decrease from +2 to what? 0. And what it means that zinc oxide is reduced to zinc. That is the chemistry, that's the language we use. Zinc oxide is reduced to what? To zinc. And therefore, since zinc oxide is reduced to zinc, zinc oxide is a good oxidizing agent. Is a good what? Oxidizing agent. Okay. Now, we have already explained the key 3 definitions I gave about oxidizing agent using Redox equation. All you have here are Redox equation. This number 1, number 3, and number 4 are all Redox equation. Remember what Redox equation is? It's the equation that shows both reducing or reduction reaction and oxidation what? Reaction. That means both oxidation and the reduction reaction are taking place simultaneously. Okay? Having said that, the next we have on the slide is chemical test for oxidizing agent. How actually do you know that a substance is an oxidizing agent? Pay attention to this. This is important. This is important for those of you writing WAEC, IGCS, and the NACO exam, and other external exam. This is very important. What is the chemical test for an oxidizing agent? The action of oxidizing agent on iron 2 chloride and hydrogen sulfide is used in a qualitative analysis to identify oxidizing agents. What are we trying to say? For you to confirm that a substance is an oxidizing agent, we make use of iron 2 chloride. What happens to iron 2 chloride when you introduce an oxidizing agent? When you introduce an oxidizing agent to iron 2 chloride, the color changes immediately from green or dirty green to reddish brown or ordinary brown. What is happening? The oxidizing agent will oxidize the iron 2 to what? Iron 3. To what? Iron 3. The oxidizing agent is responsible in taking the color of iron 2 to iron 3. Take note of that. If you make use of iron 2 to test for what? An oxidizing agent, what will happen? The oxidizing agent will oxidize iron 2 to iron 3. It will cause the iron 2, which is what? A reducing agent, to enter into what? Iron what? 3. The color is there to help you. Iron 2 chloride is dirty green in color, while iron 3 is reddish brown. So once the color changes from that of the green to brown color, that means the substance has moved from iron 2 to iron 3. Then what is the cause? The cause is because there is an agent called oxidizing agent that actually cause the iron 2 to get oxidized and enter into iron 3. I want to believe you are following up. Then another test is when you use a compound called hydrogen sulfide. Hydrogen sulfide. What happens? Immediately you will notice a yellow deposit of sulfur. A yellow deposit of sulfur. You have hydrogen sulfide, right? What will happen when you introduce an oxidizing agent? This hydrogen sulfide will cause this sulfide to move to ordinary sulfur. And this ordinary sulfur is yellow in color. Is what? Yellow what? In color. The oxidizing agent you are adding here, will cause this hydrogen sulfide to move to a neutral sulfur. That means, what's the oxidation number here? 2. So you'll be moving from where? From sulfur 2 minus to what? Sulfur what? 0. What is happening? From -2 to 0 is an increment. That means oxidation is actually taking place. What is the cause? What actually caused a substance moving from what? -2 oxidation number to 0 oxidation number is because there is what? An oxidizing what? Agent. Because what actually is happening here is what? Oxidation, which is loss of what? Electron. Can you see it? So an oxidizing agent will cause ion 2 to move from green color towards reddish brown. That is what an oxidizing agent will do. An oxidizing agent also will cause hydrogen sulfide to deposit a yellow precipitate, a yellow color. If you introduce an oxidizing agent in hydrogen sulfide, there will be a yellow deposit of sulfur. Yellow deposit of sulfur. What is actually happening is this. The sulfur in this hydrogen sulfide has oxidation number of -2 and moving to neutral sulfur, which is what? Oxidation number of 0. So that means oxidation number actually increased from -2 to 0. From -2 to what? To 0. Okay, that is that. That is that. So in summary, we can test for oxidizing agents using that of the iron 2 chloride and the hydrogen sulfide. Then how do we test for reducing agents? Reducing agent is part of the Redox equation. Okay, it's part of the Redox equation. So what do happen in that? What do we use to test for reducing agents? What can we use to test for reducing agents? What can you use to test for reducing agents? We use chemicals like acidified potassium tetraoxomanganate 7. Acidified potassium tetraoxomanganate 7. What happens when you put potassium tetraoxomanganate 7 to a reducing agent? The compound will definitely move from a purple color, KMNO4, to a colorless substance, which is MN2+. What is happening here? This particular compound is purple in color. It's purple. So when you introduce a reducing agent, when you introduce a reducing agent, what happens? The reducing agent will cause the purple color to turn to colorless. To turn to what? Colorless. To turn to colorless. To turn to colorless. That is how we test for what? A reducing agent. The acidified potassium tetraoxomanganate 7 has a color. What is the color? Purple color. If you introduce a reducing agent, it goes to colorless. If you don't want to use that, you can test a reducing agent using acidified potassium heptaoxodichromate 6. What happens? This one is orange in color. Orange in color. Once a reducing agent enters, it will turn to green. It will turn to green. With this chemical test, you can identify reducing and oxidizing agents. You can identify reducing and oxidizing agents. Okay, at this point, we have some examples of oxidizing agents and examples of reducing agents. We have examples of oxidizing agents and examples of reducing agents. Generally speaking, most reactive metals are reducing agents. They cause reduction reaction. Most non-metals, reactive non-metals, are reducing agents. Reactive metals such as the group 7 element, the halogen, and other ones coming from group 6 and group 8, they are good oxidizing agents. I repeat, reducing agents, reactive non-metals are oxidizing. Apart from this, other examples of reducing agents you should know are carbon 2 oxide, which is carbon monoxide, is a reducing agent. Hydrogen sulfide is a reducing agent. Sulfur 4 oxide is both oxidizing and reducing agent. Concentrated Okay. Concentrated tetraoxosulfate acid is an oxidizing agent. Concentrated triosonitrate acid is oxidizing agent. We have good number of them. So I want us to ponder or see some questions regarding to this topic. We have come to the end of this topic. Let us look at some questions from these topics. Let's go now. Let's see how we can answer some questions from here. Let's look at the first question. Consider the following reaction equations. We are seeing chlorine reacting with ammonia to give us nitrogen and hydrochloric acid. And the question is, what is the function of ammonia in this reaction? Is it an oxidizing agent, reducing agent, a dehydrating agent, and a drying agent? No, it is not a dehydrating agent. It is not a drying agent. You shall be considering that of the oxidizing agent and reducing agent. Now look at the reaction. Look at the reaction. If you watch, chlorine itself here moved from chlorine 0 neutral atom moving to hydrochloric acid, which has a +1. Can you see that? So in here, ammonia is a reducing agent, while chlorine is an oxidizing agent. Let us check the answer. The answer is reducing agent. Ammonia is a reducing agent. That is C. Let us check. Yes, that's correct. That's correct. Ammonia is a reducing agent. Let's go to the next question. What is the change in the oxidation number of iodide ion in the reaction represented by the following equation? Iodide ion. That means is actually moving from -1. Where can we find iodide ion again in the right-hand side? That is when it becomes neutral. When you have just neutral. That means from -1 to 0. -1 to 0. Is it an increment or a decrement? Do you think the number decrease or increase? From -1 to 0, that means it's actually increased from -1 to what? 0, because 0 is greater than -1. So the answer is actually D. Let's check. The answer is actually D, -1 to 0. Let's check the answer. Let's check. We are correct. Can you see that? Can you see that? Let's move to the next. Let's move to the next. The next question says, reduction is the process of that. Addition of electromagnetic element? No. Reduction is loss of electron? No. Loss of oxygen? That is reduction. Loss of hydrogen is oxidation. So the correct answer there is C. Loss of oxygen is reduction, while gain of oxygen is oxidation. So the answer is C. Let's check. Loss of oxygen is reduction. Let's check. Fantastic. We are there. We are there. Let's look at the next question. The next question is, okay, that one is a radioactive, radioactive nuclear reaction. We're not talking about that. Let's look at the next question. The oxidation number of sulfur is +4 in which of the formulas below? The first one here, oxidation number here is +6. Second one, so no, the first one is +4. The second one is +6. Okay, so the correct answer is that one that has +4. This is what? Triazo sulfate what? 4. Okay. Now let's look at D. D and A can confuse you. D does not have any charge. So the radical is not there. The ion is not there. It's supposed to carry 2 minus. So we check D. D is triazo sulfate 4 acid. That means the oxidation number there is +4. The correct answer is D. Let's check. Correct answer is D. Let's look at the answer. That is correct. That is correct. That is correct. Let's go to the next question. The next question is, What is the role of Mn2 in the reaction represented in the equation? Okay, let's see. What do you think is the role of MnO4? Okay, this is actually not this particular topic, but you can still say something about that equation, right? We can still say it because for actually, okay, the reaction is not even complete. That's not an equation. It's not an equation. It's everything. There's no arrow that demarcates the reactant from the product. So that is, the equation is not complete. It's not complete. So let's look at this one. Consider the reaction represented by the equation. This is tetraoxosulfate 6 acid reacting with coke. That gives us water and sulfur 4 oxide. So you can now see that carbon moves from oxidation number of 0 straight to what? Oxidation number of what? 4. Because what I have here is carbon 4 oxide. So that means tetraoxosulfate 6 acid, which is H2SO4, is an oxidizing agent. It oxidizes carbon to carbon 4 oxide. That is option number B. Let's go. And let's check our answer. An oxidizing agent. Fantastic. That is correct. And finally, let's look at this. Which of the following equations represent a redox reaction? What is redox reaction? A reaction where oxidation and reduction both are taking place simultaneously. Both are taking place simultaneously. Let's check. Can I see oxidation here? Yes. Here from 0 to 2, that is from 0 to minus 2 is reduction. And from here, minus 2 to 0 is oxidation. Yes. Hydrogen sulfide reacting with chlorine to give me hydrogen chloride gas and sulfur is a redox reaction. So A is a redox reaction. Which of the following equations represent a redox reaction? Represent a redox reaction. So let's check. Let us check. That is the answer. You can see that is very, very correct. Thank you. Thank you for your time. Thank you for your time. Explore other questions that has to do with oxidation and reduction. I want to believe that what we have done so far will be an immense help to your learning, especially this particular topic. Thank you. Until I see you next.